Where is the center of a triangle? Seems like a simple question, but the answer turns out to be somewhat complicated. Triangles are pretty basic, the simplest polygon we can create, but there are 4 different points that we might want to consider as the center of a triangle. The circumcenter is the intersection point of the perpendicular bisectors. The incenter is the intersection point of the angle bisectors. The centroid is the intersection point of the medians. And the orthocenter is the intersection point of the altitudes. In this video, we're going to talk about how to create a sketch of these 4 different centers of a triangle, and I'll mention some of their properties as well. Let's first take a look at how to find the circumcenter of a triangle. The circumcenter, we just said, is where the perpendicular bisectors meet. So to find the circumcenter, we can identify the midpoint of each side of the triangle and then draw lines that are perpendicular to the sides at those midpoints. Where all 3 intersect, we find the circumcenter. Now it's nice because we're making a sketch. It's nice to add markings to the diagram to confirm that what we found is the circumcenter. So let me first tidy up these lines a little bit. To show that the point along each side is the midpoint, we can add tick marks. And to show that the lines are perpendicular to the sides, we can add little right triangle symbols. The incenter is where the angle bisectors meet. So to sketch the incenter, we want to draw lines from each vertex that split the angle in half. All 3 of these lines are going to meet at a single point, and that point is the incenter. Now, markings that we can add to confirm that we found the incenter are arcs. To show that these 2 angles are the same, we can add a single arc. To show that these 2 angles are congruent, we can add double arcs. And then to show these are congruent, we can add triple arcs. The centroid is where the medians intersect, and the medians are lines that go from each vertex to the opposite midpoint. So we can first find the midpoints, and to show that these are the midpoints, we could add tick marks to our sketch like we did for number 1. And then from each vertex, we can draw a line to the opposite midpoint. The place where they intersect, that's the centroid. Finally, the orthocenter is where the altitudes all intersect. Altitudes are lines that are drawn from a vertex to the opposite side and are perpendicular to that side. This happens to be an obtuse triangle. There's an obtuse angle here. And so the altitude from this vertex is going to fall outside of the triangle. To see that, we can extend this side slightly, and then drawing a line that's perpendicular from that vertex, we see that the altitude is going to be outside. In a similar way, the altitude from this vertex will also be outside of the triangle. Extending this side, I'd like to draw a line from this vertex that's perpendicular to that side. And finally, let me extend the first altitude that I drew, and we'll see that it intersects. And right there is the orthocenter. So we've drawn sketches for the 4 centers of a triangle: the circumcenter, the incenter, the centroid, and the orthocenter. Now, there are a couple interesting properties I want to mention about a few of these. It turns out the circumcenter is equidistant from each of the vertices, and so it's the center of the circle that passes through each of those vertices. So one of the things that means is that every triangle has a circle that passes through all three vertices. The incenter is equidistant from each of the sides. If we draw perpendiculars from the incenter to each side, the distance for each of those is going to be the same. And so the incenter is the center of a circle that just touches each side of the triangle. I just drew a terrible circle there, but that's the idea. And it turns out that the centroid divides the triangle into equal areas. So for example, the area on this side of the median is the same as the area on this side of the median. And in fact, the area of each of these 6 little triangles is the same. And so this special property of the centroid even means that any line, not just the medians, but any line that we draw through the centroid is going to split the triangle into 2 shapes of equal area. The orthocenter doesn't have anything quite so immediate that's special about it, but it's not without its own importance. There's something called the 9-point circle, which you can read about, that is related to the orthocenter. I hope you enjoyed the video. Thanks for watching.